Welcome to EM Pulse, bringing research and expert opinion to the bedside.
We're your hosts, Sarah Medeiros
and Julia Magana. Welcome back to EM Pulse. PCARN has been a machine lately, so we have another myth-busting article to talk about today. The myth today is that LR, or balanced fluids, is the best fluid to use in kids with sepsis. The answer is published in the New England Journal of Medicine article titled Balanced Fluid or 0.9% Saline in Children Treated for Septic Shock. To tell us the answer, we are here with Dr. Fran Balamuth, Professor of Pediatrics at the University of Pennsylvania and Division Chief of Emergency Medicine at CHOP, Children's Hospital of Philadelphia. We also have Dr. Nate Kuberman, Executive VP and Chief Academic Officer and Chair of Pediatrics at Children's National Hospital in D.C. Welcome, guys.
Thanks for having us.
Great to be here, Julia.
Okay, I really like the article title because it basically tells us the question the research team asked: does balanced fluids result in a lower frequency of major adverse kidney events within 30 days compared to normal saline in children treated with septic shock? Or which is better for the kidneys, LR or NS in pediatric septic shock? Fran, we're going to get to all the details, but let's start by cutting to the chase. After years of debate, which one is better?
Am I telling you the answer right now?
Yes, go for it.
Both work.
Oh! Okay, why did you ask this question to begin with?
We asked this question to begin with because it's been around forever. I think we as emergency providers, finding kind of the sepsis needle hiding in the haystack of children who come to us with fever has been a longstanding question, as is kind of what do we treat them with? And you all know that crystalloid fluid is the cornerstone of sepsis resuscitation, along with timely antibiotics, et cetera. And the question about which crystalloid fluid is best has been around for decades, if not longer. In 2017, the Vanderbilt trials were published, which looked at a single center but a lot of patients, so upwards of 30,000 patients across a single institution, that did show a benefit of balanced fluids versus saline in all comers, so not just in sepsis, but in all patients. And the outcome in that trial was the same as the one we used in this, MAKE 30, or major adverse kidney events in 30 days. And so we set out to answer the question definitively in children around that time.
Hey, Fran, I was just going to add, that Vanderbilt study, forgot to mention, is just in adults.
Correct, yes.
So Fran basically nailed that. We've been, looking at these fluids forever. And also, the reason why this is a big deal is that we don't have much in our armamentarium for pediatric shock. I mean, that's just the reality. We have fluids, we have antibiotics, we have pressors. But it's not like this whole spectrum of tools we have to manage it. So we just want to make sure we're getting each piece of those that we have at our disposal right. And nobody had really addressed the question the way we did.
And I guess just to give a little bit of background in terms of biologic rationale. So I think, the reason why people think that balanced fluids may be superior to saline for sepsis really has to do with chloride load. So 0.9% saline has a super physiologic amount of chloride in it. And there is strong evidence, both from kind of animal studies as well as humans, that if you get a lot of saline, it induces hyperchloremia. And that hyperchloremia may lead to kind of downstream kidney injury and then kind of downstream clinical effects from that. And so that was kind of the hypothesis driving this study. I think it is important to underscore the fact that the absolute difference that we were expecting to see was small. So we didn't hypothesize that even if balanced fluids were better, they were not going to be this like magic bullet, magical cure for sepsis. We knew we were anticipating something on the order of a 1% to 3% difference in clinical outcomes. That's one of the reasons why we needed such a big study, was because the magnitude of the effect was going to be small. So I think one of the really important questions that we wrestled with in the beginning was should we bother, right? Should we do a big giant trial that's going to take us a really long time, is going to cost a lot of money, we're going to need tons of children around the world? Is it worth it? And I think one of the reasons we decided that the answer to that was yes, was that even a small effect size, when magnified across, tens of thousands of children around the world, really does add up to something that's clinically important, especially when the intervention you're talking about is not a fancy medicine, right? These fluids are available around the world. They're cheap. They cost $1 a bag. They need no special storage. And so if we design a pragmatic study, it can be translated to the bedside really quickly, which is, why we're here, in hopes of translating these findings to the bedside quickly.
But I'm just going to highlight, and before this, the data in children were very limited. And prospective randomized trials, there had been sort of one really out there that we're aware of. So the only really big data that we had were in adults. And as Fran pointed out, that trial was a pragmatic trial, single center, although big, single center in adults at Vanderbilt. So the question had just really not been addressed fully. Now, and I was just going to add as a clinical trialist, to the question that Fran addressed about importance. We look for importance if there's a small effect even, but in a very large population. And, annually, Fran, in kids, how many cases of sepsis worldwide?
So our most recent study in the United States is about 18,000 children a year in the United States with kind of Phoenix, the sickest Phoenix-defined sepsis in the U.S. The numbers are much bigger around the world. So certainly in kind of low and middle income countries,
Right.
Infection is an important source of childhood mortality. So,
being a globalist, this intervention can be done in Nepal, in Bangladesh, in Washington, D.C., in Philadelphia, anywhere. It's just picking the right bag of fluid. So for those two reasons, a big, big denominator. There's a lot of children with sepsis around the world every year. And even for small benefit, it's a lot of human lives and something that can be done in basically any setting because it's a very low cost, widely available intervention.
So we need a large trial. We need an international trial. You guys did this really big. Tell us a little bit about how you answered the question. Who was enrolled? Walk us through it all.
Yeah, so we designed a pragmatic trial. So our goal sample size we knew was going to be close to 9,000 children. And so in order to do that, we kind of had to gather a village. So maybe I'll let Nate talk a little bit about the village, and then I can talk about the design of the study.
As Fran mentioned, just given the numbers that we needed when we were designing the trial, we thought this is going to have to go beyond the United States because there's just not enough children that we would be able to enroll in PCARN, despite it being a very large research network. So we had to be, very creative and engage our collaborators and friends around the world. Fortunately, there were several good things in our favor. PCARN is the only federally funded research network in pediatric emergency care in the United States, but we do have sister and brother networks around the world. So PREDICT is in Australia and New Zealand, PERC is in Canada, and there are others. We realized that we would be able to achieve the sample size if we were able to engage all of our partners. Fortunately, we had done this before, not in a prospective trial, but retrospectively. We actually kind of globally created this global network called PERN with the creative name Pediatric Emergency Research Network. In the H1N1 pandemic, if you recall, swine flu, 2009, we were all faced with this issue of which children presenting to the emergency department with influenza-like illness actually has H1N1 and is destined for more serious outcomes. That was a question that we all faced. So all these networks, we were at a meeting of child health in Amsterdam, and we just had this random gathering, and we decided, hey, why don't we try to answer this together? And so we organized a big retrospective case control study. It was eventually published in British Medical Journal. Important article, but what it did is it really established a bit of a framework in which to do collaborative work. And so we went to our partners, and they were, of course, also very interested because of the pressing nature of this question. And, I won't get into all the details, but one of the great pieces of news, we would have enough patients, we'd have wide generalizability. The challenges, however, when you do international collaboration, data sharing agreements, how do you do a consent in the emergency setting? It's all different in different nations. The Data Safety Monitoring Board has to be international participation. But all of those were achievable, and we were able to overcome as long as we could get the funding and the financing to make it work. And Fran and Scott led a grant that we submitted to the NIH, and with the NIH knowing that we would not be able to enroll enough patients in the United States, but we were funded sort of conditional on that we would be able to get funding from elsewhere in other countries to hit that number. So we basically shared the grant with our colleagues in PREDICT in Australia and New Zealand, and in PERC in Canada. They submitted it to their federal funders. They got it funded. And then Fran and Scott got a separate grant in the state of Pennsylvania. And when you put together all 4 of these grants, now we had the money, we had enough patients, and then Fran can describe the trial.
Fran, tell us a little bit how you actually answered this question. And what is a pragmatic trial?
So there's a couple of big differences, I think, between pragmatic trials and kind of traditional trials that I won't spend a lot of time on this, but really I think pragmatic trials means that the goal of it is effectiveness, not efficacy, right? So we know that we'll be enrolling a slightly messier population, but the advantage of enrolling that messy population is that it was done kind of by clinicians in real world settings, so it's more easily applicable to real life, which we hope our findings are. So the inclusion criteria for the trial were very pragmatic, right? The enrollments were done by clinicians in participating emergency departments. And really, there were 2 inclusion criteria. One is that the clinician suspected sepsis, and 2 was that they intended to treat with at least 2 fluid boluses for either poor perfusion or hypotension. And that suspect sepsis piece obviously has some subjectivity to it. So we did give some guidance to clinicians as to kind of what does that mean. But really, it was, in the opinion of the treating clinician, do you suspect sepsis, and are you going to give at least 2 boluses? And we allowed each site kind of some leeway to operationalize that based on their own infrastructure. We did take advantage of the fact that there's been a lot of sepsis quality improvement work around, especially the United States, where developing sepsis recognition tools and processes whereby teams can kind of have a shared mental model around treating a child with sepsis. And so many sites now have kind of sepsis alerts and sepsis huddles and sepsis order sets. And so people within a given site know kind of what suspected sepsis means locally. And so we were able to allow sites to kind of use whatever tools they had locally to operationalize it. But really, it's the clinician suspicion that was the driving force.
Taking just a quick step back to the pragmatic nature of the trial, in addition to what Fran said, as opposed to many of the other PCARN studies that your listeners, Julia, have heard about, one of the things that also made this pragmatic is that the data collection form was just one side of one sheet of paper. We needed to make this really easy, really fast, enroll the population that Fran's talking about, as opposed to some of these other big PCARN studies where we gather 6 and 7 sheets of data. We realized, the limitation, of course, is we can't answer that many clinical questions based on the form, but it makes it very feasible and very doable.
I remember enrolling kids in this study, and it was 2 months of age to 18 years of age, right? And they could not have received 40 ml per kilo or more of fluids, right? They had to have received less than that so far. And I remember we'd get to enroll them with EFIC, do a real quick consent for just like making sure everything was okay if they weren't too sick. And then we would open up the envelope and you would be randomized to normal saline or LR, and they would receive the rest of their fluids or their initial fluids, hopefully in that. And then it would be for another 48 hours, right?
Yeah, so there were a bunch of exclusion criteria. So inclusion criteria were simple, but there were a handful of exclusion criteria just to ensure safety. So if there were a situation either where the clinician felt like it was unsafe to randomize the patient, or the patient had a known condition in which we felt like a certain fluid would be unsafe. For example, like patients who were on dialysis were excluded from the study because the little bit of potassium that's in balanced fluids could be potentially dangerous to them. Patients with known inborn errors of metabolism were excluded kind of for similar safety reasons. So there were kind of safety exclusion criteria. And then I do think it's also really important to underscore kind of the consent mechanisms for this trial, which were different across different countries. But because, sepsis is an emergency that we need to treat in a very timely fashion, there wasn't time for prospective informed consent in the vast majority of patients in the study. So the United States operated under the exception from informed consent, or EFIC. The process that Julia described is kind of an opportunity to opt out initially, kind of in real time, but there is no prospective consent for the study unless there is time to have a true informed consent discussion. And then patients and families are given the opportunity to opt out or withdraw from the study later. Our international partners had a slightly different mechanism that involves kind of deferred or delayed consent in Australia, New Zealand, and Costa Rica.
And this was done at 47 emergency departments in 5 countries. You enrolled 9,041 patients, right? Approximately half into the balanced fluids and half into the saline group. And the primary outcome, you mentioned this before, was the MAKE 30, which is major adverse kidney event within 30 days. Why did you choose that outcome?
So we chose MAKE 30, or major adverse kidney events within 30 days, it's a composite endpoint that includes death, new renal replacement therapy or dialysis, and then persistent kidney dysfunction, which is defined as your last creatinine before discharge or 30 days has to be at least twice your baseline. And this was the same primary outcome that was used in the Vanderbilt trials that we mentioned in the beginning, and really is kind of like an NIH recommended outcome for kidney injury. And because that kind of hyperchloremia mechanism that we talked about in the beginning, it was hypothesized to act primarily through the kidney, we thought that this made the most sense for the primary outcome. And I think, Julia, you had mentioned earlier the intervention, which I think I kind of lost that in our other discussion. But just to remind everybody that, once patients were randomized, the study was not blinded, so they were allocated to either receive saline or balanced fluids until 11:59 p.m. the next calendar day. So everybody got between 24 and 48 hours of fluid. They could give whatever balanced fluid they wanted. So it could be LR, it could be Plasmolite. And really everything else about the patient's care was dictated by the treating team. So the only thing the study asked to control was the kind of fluid. But, whether they got fluid, how much they got, any other medications, et cetera, all of that was at the discretion of the treating team. And then we followed patients through discharge or 30 days, whichever came first. And like Nate said, we had a very pragmatic approach to data collection. So the kind of enrollment form in the ED was a single page. And then we had medical record review by research coordinators at each site that collected the outcome data through electronic health record review.
Okay, we already know the punchline. There is no difference. On a scale of 1 to 10, Fran, how surprised were you?
I have to say I was not super surprised that there was no difference. So we saw MAKE 30 in 3.4% of the patients enrolled in the balanced fluid arm and 3% of the patients in the saline arm. The confidence interval crossed 1, and there was no difference. I think given kind of the number of patients that we enrolled, the broadness of the population, I'm not super surprised that that's what we found. I guess the other reason I wasn't surprised was because although the Vanderbilt trials did find a difference, almost a decade ago now in 2 single center studies involving adults, there have been a couple of big studies since that time that have not shown a difference. A big trial in Canada, and then actually like 3 days before this study was published, a Cochrane review was published that didn't include the data from our trial because it wasn't yet published. But the conclusion of the Cochrane review was that there was no difference between balanced fluids and saline. So I think this is probably not surprising at the end of the day.
Yeah, it's interesting. I was probably like a little bit more surprised than Fran because, it's funny. This is the problem with human bias. We all wanted to see a difference in one or the other. I didn't have a strong feeling of either direction. But you know what? I kind of was swayed by the Vanderbilt trial because it was a really big study and the differences they showed were quite large. But for me, the take from that is that, first of all, that was in adults, remember, not children. But it goes back to my fundamental core belief as a clinical trialist. There is nothing like the big, well-controlled, randomized, prospective, multi-center clinical trial to answer a question with definitiveness, with generalizability, et cetera. But it's funny, we all get swayed or moved by one study or another, and I was a bit swayed by the Vanderbilt study, but I believe our study.
I think definitive data that's really helping to answer this question. Were there any subgroups that were maybe more nuanced and showed a benefit for one fluid type over another?
So just to take one step back, so we didn't see a difference in the primary outcome. We didn't see a difference in any of the components of the primary outcome. So no difference in death, dialysis, or persistent kidney dysfunction. And nor did we see a difference in any of the other clinical secondary outcomes, so like hospital length of stay or 90-day mortality. But we did, however, see some biochemical differences in patients. So the patients in the normal saline arm had higher levels of hyperchloremia and higher levels of hypernatremia. And the patients in the LR, the balanced fluid arm, had higher levels of hyperlactatemia. So I think, number one, that gives us confidence that the patients got what we intended them to get, right? That the sites did a good job.
Such a good point.
Of kind of adhering to the plan. So that was good news. But I think the other thing is that despite the fact that we saw these biochemical differences, those didn't translate into clinical differences in terms of the kidney injury and the mortality that we measured.
people tend to give LR in adults, probably because of the Vanderbilt study, right? Showing it's superior in sepsis. Why do you think, is it different physiologically in kids, or is there some other thing that may suggest that this study showed a difference here?
Interesting, before the study was conducted, surveys had been done in emergency departments and ICUs, pediatric emergency departments and pediatric ICUs, about what is the preferred fluid to use in kids getting fluid boluses. I mean, in this situation. In pediatric EDs, Fran, you could correct me, but I think it was greater than or equal to 98%, as opposed to the pediatric ICUs, where it was more like 50-50, equally balanced. So it's interesting. And again, going to this issue of belief system, and also the issue of perhaps spectrum bias. That is, in the ICU, perhaps they feel that balanced solution is better for sicker patients, and that's why it's given more there. In the ED, we see all comers, and we give a saline. But it was interesting before the trial, that discrepancy between the PEDS ED and the PEDS ICU.
Okay, obviously fantastic trial. Tell me about some of the limitations to this study.
Yeah, so I think every study has limitations. I think the most interesting thing that probably will provoke the most discussion is kind of who the patients were who were enrolled in this trial, right? So if you look at kind of how sick they were, right, about 15% of the patients in the trial ended up on vasoactives. Around 10% had invasive mechanical ventilation. And so I think from an ICU perspective, right, people would say, okay, these patients weren't that sick. I think if you look at sepsis epidemiologic studies using the kind of ED population when patients walk in the door, the patients we enrolled have a lot of face validity because that is kind of the population that we enroll from the ED. But I think if you're looking at this from the lens of the intensive care unit, you might think that the patients, maybe are less sick, which they are. And, we had a lot of discussion around this in the beginning of the trial, kind of how should we do this study, right? Because the patients who are most likely to benefit from a change in fluid are not patients who are getting, 40, 60 per kilo of fluid. Those patients are pretty unlikely to die or need dialysis at baseline. But if we waited until, the ICU to enroll patients, we wouldn't have been able to include the fluids that they got during their initial resuscitation because they're resuscitated by the time they get to the ICU. And when they arrive at the ED, we don't necessarily know who's going to get better after a couple of boluses or who's going to need more. And so in the end, we decided it was more important to get patients from the beginning of their resuscitation. But we knew that the kind of downside of that was going to be that we would enroll some patients that turned out to get better quickly. And so that we may dilute our effect a little bit. We did try, and we have some planned analyses to try to look at the sickest patients in the study in more detail. I think, Julia, you had asked the question about patient subgroups. And we did kind of both planned and ad hoc analyses of a whole bunch of different subgroups of patients. And the kind of 20,000-foot view is that we saw no statistically significant differences in any of the subgroups that we looked at. But, the point estimate for MAKE 30 does kind of flip to the other side of the line when you get to the sickest patients who had the highest lactates on arrival, who had the most acidosis on arrival. And so, we didn't have a ton of those patients. So I think we can't make, the firmest conclusions, I think, in the sickest patients. We can't fully exclude benefit. So I think that is an important caveat to note.
Okay, let's talk about how you guys are going to apply this on your next shift. How do you use this information?
I think the translation is pretty easy. If you have a patient in front of you where you suspect sepsis and you're going to treat with crystalloid fluid, you can use whatever you have. Both fluids, balanced, saline, are safe, and both are effective for pediatric sepsis. And you can treat the child in front of you if you think, there is a reason to give one or the other, or you're aiming to treat, minimize biochemical differences. You can make whatever choice you want to make, but both are safe and effective.
And I'll just add to that, Julia, that totally agree with Fran. I'll take whatever bag is in front of me between balance and saline. If you asked me and I was an ICU physician, I would still say the same answer. And to be clear, this study did not answer this question. But if I had a patient in the ICU that had ongoing, fluid requirements and was really sick, perhaps at some point I might consider changing to balanced fluid. Again, we didn't answer that, and that wasn't the question at hand. But for us in the emergency department, I'll take whatever's in front of me.
Thank you both. Anything else you think we need to learn or talk about or think about from this study?
I'll just say just one thing, just in terms of Moving forward in the current era, I think what this study spiritually showed, besides answering what we consider a really important question that will reassure people around the world who only have access perhaps to one fluid or the other, that they know they're doing the right thing, whichever fluid they're using, is that to answer like the big pressing questions, particularly in our field in pediatric emergency care, frequently you need to do multi-center studies. As you know, that's what PCARN is here for. But sometimes you really need to do global studies. And rather than what historically networks around the world in our field had been doing, is we've been kind of answering the same questions, but just some folks in Europe would do it, or Australia, New Zealand, or us in the United States, and we were just duplicating each other. When you have a big randomized trial, you come to the same answers. What we really should be doing is we should be collaborating more. And there's two ways to collaborate. Either when in a study like this one, when you actually need more patients than any network has, then you collaborate. Otherwise, even if you do have enough patients to answer a particular question, it would be great if all of us peds emergency care networks just took on a different aspect of the question. So rather than reproduce each other's results, which we do all the time, we could answer different aspects to make greater use of a limited resource world.
And I think I would just also underscore the team aspect of this, right? Like, this was a team effort not only across all the different sites in the study, but also across disciplines, right? So every site had a site PI that was an emergency physician, but every site also had an ICU partner. The study was, co-led by me and then Scott Weiss, who's a, pediatric intensivist. And so I think this really hopefully built infrastructure to answer not only this question, but, additional questions that could come forward in the future for kids with sepsis.
I have to say, I love this. I love it because it's another myth busted. And there are so many myths in medicine that really need a good trial like this, international, national, to really answer them. And I personally am a fan that the answer is there is no difference, because it means that we can treat the child in front of us with the resources in front of us, instead of having to go in and teach somebody a new tool, restock things differently. Like, you get to use your physician judgment and with the resources that whatever it is that you have in front of you. So to me, it's a very freeing answer. And I think that it's going to be really wonderful for the future. Thank you to our department at UC Davis for enrolling patients in this study. And thank you to OM Productions for creating a balanced production. Until next time, stay curious, stay inspired, and stay tuned.
The opinions expressed on this podcast are those of the hosts or guests and do not necessarily reflect the views of UC Davis Department of Emergency Medicine, UC Davis Health, or their parent organizations.